All right, so today we're going to take a look at questions 14, 15, and 16 from the SAT Practice Test 9 calculator section. So let's start with number 14. A company purchased a machine valued at $120,000. The value of the machine depreciates by the same amount each year so that after 10 years, the value will be $30,000. Which of the following equations gives the value V of the machine in dollars T years after it was purchased, given that T lies in between 0 and 10? So to start things off, let's start constructing an equation based on what we know. We know that the initial value is $120,000, so let's write that. And we know that after each year, it depreciates by the same amount. So this is basically saying that it's being decreased by a constant factor. And we don't know this constant factor, so we'll just write M for it. And this is equal to V. So now all we have to do is solve for M. Luckily, it's given to us that after 10 years, the value will be $30,000. So all we have to do is plug 10 in for T and 30,000 in for V. So let's quickly do that. 120,000 minus 10T equals 30,000. And now at this point, we just need to use basic algebra to solve for M. This should be M rather. So let's subtract 120,000 from both sides to get negative 10M equals negative 90,000. And then divide by negative 10 to get M equals 9,000. And so the constant factor that is being decreased by each year is 9,000. So now we can write the full equation, which is 120,000 minus 9,000 T equals V. And if we look at our answer choices, this is corresponding to answer choice B. So that's going to be our final answer. So that's how you do number 14. Let's move on to number 15. Line M in the xy plane contains the points 2, 4, and 0, 1. Which of the following is an equation of line M? So we're going to construct this equation using slope-intercept form, which is y is equal to mx plus b, where m is the slope and b is the y-intercept. And we can't solve for b at all yet, so let's just ignore that. We're going to solve for m first using an equation that you're probably familiar with at this point, which is y2 minus y1 over x2 minus x1. We used this equation quite a bit in the past. So we're given our y and x values from these 2 points, 2, 4, and 0, 1. So let's just plug that in. Let's use 2, 4 as our y2, x2 point and 0, 1 as our y1, x1 point. So 4 minus 1 over 2 minus 0. And this is going to give us 3 over 2. So that is our slope. That's our m value. So now the equation we have is y is equal to 3 over 2x plus b. And to solve for b, all we have to do is plug in the values of a given point. Let's use 0, 1 because it'll be a little bit simpler. So plug in 0 for x and 1 for y. 1 is equal to 3 over 2 times 0, which is 0, plus b. So we know that b is equal to 1. So now we can construct the final equation, which is y is equal to 3 over 2x plus 1. So that's going to be our final answer, and that corresponds to answer choice D. So that's how you do number 15. Let's move on to number 16. In the expression above, A is constant. If the expression is equivalent to Bx, where B is a constant, what is the value of B? So let's start off by simplifying this expression. We're going to multiply these two polynomials out using FOIL, which is first, outer, inner, last. And then we're going to just add on this and combine like terms to simplify it. So let's start off with using FOIL to multiply out these two polynomials. So first is going to be 4x times ax, which is 4ax squared. Outer is going to give us 4x times negative 1, which is negative 4x. Inner is going to give us 4 times ax, which is 4ax. And last is going to give us 4 times negative 1, which is negative 4. And don't forget to add on negative x squared plus 4. So minus x squared plus 4. Now, at this point, we're just going to combine like terms to make this a little bit less messy. So we're going to write it as 4ax squared minus 4x plus 4ax. Notice we cannot combine 4x and 4ax because we don't know what a is yet. And we can combine -4 and 4, so that'll cancel out to give us 0. And we're just left with minus x squared, which we cannot combine with 4ax squared because, again, we don't know what a is. So at this point, let's make this a little bit cleaner. Let's merge together 4ax squared and -x squared, as well as -4x and 4ax, and let's see if we can factor anything out. So 4ax squared, we're just going to rewrite this so that our similar terms are next to each other so we can factor it out more cleanly. Plus 4ax minus 4x. So at this point, we can factor out let's group this together. So at this point, we can factor out x squared from this and x from this. Let's do that. 4a minus 1 times x squared plus 4a minus 4 times x. Now, at this point, we can't do anything else because we don't know what a is. Luckily, it's given to us that this equation is equivalent to bx. So we can just set this entire expression equal to bx. And now we can just compare our two sides of the equation. So we know that on the bx side, there's no x squared value, which means that the constant in front of x squared has to be equal to 0 since it does not exist on the other side. So we can safely assume that 4a minus 1 is equal to 0. And that will tell us that 4a is equal to 1, which is very helpful for this next step. This is just what we need to solve for b. So now let's ignore this because we've pretty much we've explained why this is equal to 0. So just forget about this. Let's just focus on this part of the equation. 4a minus 4 times x equals bx. Now, we can cancel the x's out to make it look like 4a minus 4 equals b, which is what we're going to do because we need to solve for b. And at this point, we know that 4a equals 1, so we can just plug that in. And we're going to do 1 minus 4 to find b, and that is equal to -3. So b equals -3. And that corresponds with answer choice B. So that's going to be our final answer for number 16. This one's a bit trickier, but just use critical thinking to try to solve it.